Hello and welcome to your math lesson for today. So we're working on Module 3 and this is going to be actually Lesson 3. So the learning target for today is I will be able to interpret the unit rate as slope. I will be able to interpret the unit rate as slope. So Lesson 3.3, interpreting the unit rate as slope. So last year, in your Go Math 7 class, one of the units that you guys do is finding out unit rate. So there was a point where you guys had some different things in class and you were finding out what the unit rate was. Like for instance, there's some frozen meals, healthy choice meals I like to get. And so right now, when I was just at the grocery store a few days ago, I could get 5 for $10. Okay, so I can get 5 different meals for $10. What is this unit rate? So how much is 1? Unit rate is how much does 1 item cost? So in my particular example here, when I was grocery shopping and I got 5 of them for 10, how much does 1 of my meals cost? Okay, well, I'm going to take my money and I'm going to divide by 5 and I end up with $2 per meal. So my unit rate is $2 per meal. Okay, so now in here, a storm is raging on Misty Mountain. The graph shows a constant rate of change, so we can see that we have a straight line here, and this is a proportional rate of change because it's going through this origin here. Okay, it's going through 0, 0, so I know that this is proportional. So part A says find the slope using points 1, 2. So if I go over 1 up 2, I have that ordered pair right there, 1, 2. And they say also 5, 10. So if I go over 5 all the way up to 10, I have this ordered pair, 5, 10. Now they want us to find the slope here. So remember slope, I'm going to find the change in the y over the change in the x, which means I'm going to take my 2 y values and subtract them. And I'm going to take my 2 x values and subtract them. So remember when we write ordered pairs, it's always x, y. So that y value is second. So I'm going to take this number minus this number on top. So 10 minus 2. Those are my y values and my x values go on the bottom. So if I started with 10, I have to start with 5 minus 1. So 10 minus 2 is 8, and 5 minus 1 is 4. So this would be 8, 4, 4, but we always reduce everything. So when we divide by 2, when I divide by 4, 8 divided by 4 is 2, and 4 divided by 4 is 1. So find the unit rate is going to be 2 inches per, and what are we doing this in? Per hour. Okay, so I found 2 inches per hour. So we found the slope to be 2 inches per hour, and now find the unit rate by looking here. And so if I go up to 1 hour, it's over here at 2. So 1 hour, that's what I want to find, is 1 hour. So that's where 1 would be. And the fall was 2 inches. So it's 2 inches per hour. Now look at the slope. The slope was 2 over 1. And then I also got here when I did this ordered pair, and it was 1, 2. 1 for the x value indicates unit rate. So 1 unit, and then the y value is 2. Well, that's what we got when we did the slope. So there's a unique point on the graph that gives you the slope. If it is proportional, meaning it goes through the origin, this is going to work. Okay, so every single time you do that. So the unique point here that they're talking about, whoo, that just flipped up on me. That unique point here is 1, 2. When this x value is 1, then this is going to be the unit rate if it is proportional. Okay, so if it is going through 0, 0, so if it goes through that ordered pair, 0, 0. Okay, and we could tell by that graph that it was. All right, let's look at another sample problem here. All right, so graphing proportional relationship. So every 3 seconds, this cube, for every 3 seconds, 4 cubic feet of water pass over a dam. So look at the graph here. Do you see how this graph goes through this origin right here at 0, 0? So what this is saying, that when we find the slope, that is also the unit rate. So unit rate and slope are the same when it is proportional and it goes through the origin. Okay, so when proportional, which means it goes through this origin. So if we count the rise here, it is rising 8 over 6. So that simplifies to 4 over 3. Okay, now how can we tell if this goes through 0, 0 or not from a chart? Well, look at the pattern. 15, 12, 9, 6, are they going by 3s every time? So after this would be the number 0, and this pattern's going down by 4, so that would be 0. So you can see on the chart, it's going through 0, 0, and then we would take any one of these ratios. They already did 8 over 6, so let's do the next one. Let's do this one. So if we take 12 over 9, because remember, y always goes on top, and then x. And now if we divide by 3, we get 4 over 3. So we have 4 divided by 3, okay, which is the same thing as this right here simplified. All right, so let's look down here at the bottom, your turn. So you should be on page 84. So this is page 84. So if you didn't already have your book out, you should have it out now. And Thomas rides his bike at a steady rate of 2 miles for every 10 minutes. So let's see if we can get that on your graph. 2 miles, 10 minutes. So let's see, we got 10 minutes, and they're counting by 1, 2, 3, 4, 5. So 10 miles and 2 minutes. So we're going to go up here, 10 minutes, 2 miles. So we have that ordered pair, 10, comma, 2. All right, so find the unit rate. Well, let's see. If Thomas was not riding at all, 0, is this going to eventually go through that ordered pair 0, 0? Yep, it will. So remember, to find this unit rate, it's y over x. So in this particular rate, we have x, y. So we have 2 over 10, which is going to simplify to 1/5. Okay, so he's going 1 mile every 5, and what label was that? Minutes is what that means. All right, what do we have here? Using slopes to compare unit rates. So let's look at that graph. Oh, we better read the problem first. The equation y equals 2.75x represents the rate of barrels per hour that oil is pumped from well A. Oh, so that's well A. Okay, the graph represents well B. So this graph is B, and this chart is well A. Okay, they want us to compare which one pumps oil at a faster rate. Well, we can see that well A, they gave us that equation, is y equals 2.75x. So now let's go through the work and find out what well B is going to be. So it's going to be y equals, we need to find this number right here. So remember, if this is a nice straight line and it's going through the origin, we can take any ordered pair and do y over x to find that. only because it's a straight line and going through the origin. So it looks right here, if I go over, what are they counting by? 2, 4, 6, 8, 10. So that number right there must be 4. And if I go up here, it comes over to 10. So remember, we need to do the y value. This is y, this is x. So the y value there is going to be 10 over 4. So if I divide by 2, I get 5 over 2. Now grab your calculator. You can either take 10 divided by 4 or 5 and divide by 2, and we get 2.5. So now we're going to put 2.5 in here. So which is pumping rate oil at a faster rate? Well A is 2.75 barrels per hour, and well B is 2.5. So now, can't we say that well A is pumping faster? All right, I think that brings us to our homework for this particular, I think, you know what? I think there was one more down here at the end that I wanted to run through. Okay, so the equation here of y equals 375x represents the relationship between that a plane flies in hours and the y distance for a plane A. The table is plane B. Okay, so they want us to compare plane A to plane B. Well, we got to find out what plane B's equation is. Okay, so plane B's equation, remember, we are going to do y over x. This is x, this is y. So you put your y value, I'm just going to use this ordered pair, 425 over 1. So it'd be 425x. Now, I could have done this one right here. So remember, we still have to put y on top. So 1700 over 4. And what is 1700 divided by 4? So grab your calculator. 1700 divided by 4 comes out to 425. They're telling us that this is the constant rate, so we could pick any one of those ordered pairs and make sure you do y over x. So plane B is y equals 425x. Plane A was 375. So which plane is flying faster? In this particular case, we can say plane B. All right, good luck on your homework.